your work is fixing machinery and keeping it running, your job involves bearings. Bearings come in many different varieties, but perhaps the most common of all is this kind, a sliding surface type called a journal bearing. Chances are, many of the machines you'll work on use journal bearings or other sliding surface bearings to support their shafts. In this program, we're going to see some typical examples of sliding surface bearing maintenance. This ring-oiled journal bearing is our first example. We'll see how it's disassembled, how its clearances are checked, how a new bearing's scraped to fit a shaft, and how the whole thing fits back together when you're done. Our second example's another common sliding surface type, a tilting pad thrust bearing. Thrust bearings are designed to handle axial loads. They prevent movement of a shaft along its length. Tilting pad thrust bearings have a collar on the shaft and either one or two sets of pads called thrust shoes that provide the actual bearing surface. We'll be looking at typical maintenance procedures for tilting pad bearings. We'll see how to check clearances by taking a thrust reading and learn how to remove and replace the pads. We'll also see how to reassemble the bearing and how to break it in correctly so it's less likely to fail in the future. Let's start with you. How are you going to know when a bearing needs maintenance? Well, often someone will tell you there's a problem. For example, your supervisor could tell you that a bearing's been running at unusually high temperatures. If you're going to check it out, here are two essential items: the manual from the manufacturer and your plant's maintenance records for the machine. These are important because they list specifications, clearances, lubrication, and operating temperatures. If you're going to figure out what's wrong, first you have to know what's right. If bearings are reported to be running hot, your first step is to find out how hot with this device, a pyrometer. A pyrometer's an instrument for measuring heat. Our mechanic will be checking both of the bearings on this pump. First, he feels the thrust bearing to see if the casing is hot to the touch. Then, before using the pyrometer, he listens to the bearing with a sounding rod. While the shaft's rotating, rumbling or grinding noises coming from the bearing housing can indicate excess of clearances between the shaft and the bearing, or other bearing problems such as lack of lubrication, misalignment, or damaged parts. When he's heard enough, the mechanic unlimbers the pyrometer and checks the temperature of the housing. The correct method is to apply the tip to several different places on the housing and read the dial in each position. Checking several different places on the housing helps you detect any especially hot areas. This bearing is definitely running at a temperature far above normal. After taking a last reading on the thrust bearing, the mechanic walks around the pump to check the journal bearing on the other side. He goes through the same steps over here. He feels the housing, listens with the sounding rod, and measures the bearing's temperature with the pyrometer. This one's also running hot. We've got a problem. So the next step is to have the pump stopped and tagged out.
When you're doing this kind of work, an operator or a supervisor will be responsible for having the machine secured and tagged out properly. The tag means that the pump is down for service and shouldn't be started again until the tag's removed by a designated person. And so far, we've seen the first two steps for any kind of bearing maintenance: checking the symptoms while the machine's running, and then shutting it down and tagging it out. Now we're going to follow this particular job right on through to the end, the operational test. This is a boiler feed water pump. It's a multi-stage centrifugal type, and it has two bearings. The first one we're going to look at is over here. It's a journal bearing. It supports the weight of the shaft and handles the radial loads caused by the shaft's rotation. Let's see what it looks like inside. When the housing's removed, this is what you'll see. A two-part bearing shell, 2 oil rings, and 4 bearing inserts. 2 fit into the top shell, and 2 fit into the bottom. These soft babbitt inserts actually bear the load. The oil rings turn on the shaft as it rotates, bringing oil from the reservoir up to the top of the bearing, so it can provide a film between the bearing inserts and the shaft. When we work on this bearing, we're going to be primarily concerned with proper clearances. We have to make sure that there's the right amount of space between the bearing and the shaft. If there's too great a clearance, the shaft won't be properly supported. It'll wobble, bounce, make noise, heat up, and generally destroy itself and the bearing. If the clearance is too small, not enough oil gets in between the bearing and the shaft, causing friction and overheating, which eventually result in bearing failure. This journal bearing's the first one we're going to look at. When it's back together, we're going to move to the other end of the pump and work on the thrust bearing. Actually, this one's a combination journal and thrust bearing. It supports both radial and axial loads. On this particular multi-stage pump, one side's at a higher pressure than the other, and that pressure creates an outboard thrust on the shaft. It tends to push it in this direction. The thrust bearing keeps that tendency under control.
Here's how a tilting pad thrust bearing works. Inside the housing and underneath the top shell is a thrust collar and 2 sets of pads called thrust shoes. The shoes are held in place with support brackets on either side. When there's an axial load on the shaft, the shoes pivot on their mounts, distributing the force and preventing excessive axial movement of the shaft. Since this bearing also has to handle radial loads, it's equipped with journal inserts as well. But there are no oil rings. This bearing is force feed lubricated. An oil pump forces lubricant into the bearing. It's driven directly by a gear on the end of the shaft. The oil pump keeps lubricant constantly circulating through both bearings. Oil drains from both housings into an oil cooler, a heat exchanger that transfers the oil's heat to a flow of cool water.
From the cooler, oil is pumped up into the side of the thrust bearing and sprayed directly on the thrust collar and the shoes. Now another pipe leads into the bottom of the journal bearing housing, where the lubricant is picked up by the oil rings and carried up to the top of the bearing. Well, in a few minutes, we'll begin the overhaul. But before we start, I'd like to take the time to go over a few of the basic precautions that you have to take whenever you're working on bearings.
First, you have to make sure the equipment's been tagged out according to your plant's procedures. That's the only way you can be positive that no one will turn on the machine while you're elbow deep in the bearings. Second, you have to keep everything clean. Loose dirt, grit, rust can get embedded in the bearing material and cause serious damage unless everything's spotless before it goes in. Another important precaution involves lubrication. You'll have to replace the oil after maintenance to make sure the bearings get all the lubrication they need. And you have to replace it with the right grade of oil. Otherwise, there's no guarantee that the bearings will stay fixed after you overhaul them. Now here's the most important point of all. Before you start your work, read the specs. The specifications for the bearing will list a lot of information you'll need to know. Clearances, operating temperatures, oil specs, and replacement part numbers are all in the bearing specifications, or they're in your plant's maintenance records. You might also find some useful information like shaft weight, which can come in mighty handy when you have to hoist the shaft for maintenance. In a few minutes, we'll be back to start the overhaul. Until then, read through section 1 of your text and review the information we've covered so far.
Up to this point, we've learned some general information about the bearings on this pump, how they work, and how they're lubricated. We've also talked about some of the precautions you need to take whenever you work on bearings. And now we're almost ready to start disassembling the journal bearing. First, though, we have to move a couple of parts out of the way to free the shaft for hoisting later on. We have to remove this piece here, called the gland follower, and disconnect the coupling that's under this cage. Once they're out of the way, we can start on the bearing itself. I'll begin by removing the coupling guard.
The gland follower is removed simply by taking out a few bolts. Then the coupling's disconnected. This step isn't necessary on every bearing job, but in this case, it'll make it a lot easier to hoist the shaft later on. Now we're ready for the bearing. This first step is to clean the outside of the housing. Solvent and a rag is a good way to do it. Once the housing's clean, we can remove it without worrying about dropping dirt and debris inside the bearing. The disassembly starts with removing the 4 nuts that hold the housing in place. Once you break them free with a wrench, finish taking them off by hand and set them aside where they won't get lost. Once the nuts are taken off, you can remove the plugs from the observation ports. And by sticking your fingers down into the ports, you can lift the housing free. The upper bearing shell is the next part to come off. It's held in place with 2 dowel pins, here and here. But before we remove the shell, we're going to hoist the shaft. That'll make it easier to roll out the bottom shell when the time comes. For this job, you should use only nylon or another type of synthetic sling. Using a chain or a wire rope can score the shaft and cause more problems later on. Just as for any other rigging job, every piece of equipment, sling, shackle, and hoist, has to be rated for at least the total weight of the load. That means you have to determine the weight of the shaft first, and if there's any doubt, or if the weight doesn't appear in the specifications for the machine, over-rig it. It won't hurt to use a sling, shackle, or hoist that's rated for 2 or even 3 times what you estimate the shaft's weight to be. Using a safety latch on the hook is also a good idea. That'll make it less likely that anything will slip once the hoist is supporting the weight of the shaft. The shaft doesn't have to be lifted much, just enough to take the weight off the bearing. You'll be able to feel the tension on the sling once you've hoisted far enough. Now, on some bearings, we'd be able to rotate the shell and punch the pins out from the bottom. But since this upper shell isn't designed to rotate, we have to pry the pins out with a bar, using a block of wood for a fulcrum. You never want to pry directly against the housing itself. You're too likely to damage it and prevent a good seal between the halves. Once the pins are out of the way, the upper shell is ready to come off. In some cases, you might need to pry it, using a block of wood as before, but here we can just lift it off. Now you can see the inside of the upper shell. These grooves help hold the bearing inserts in place. The shell is stamped inboard and outboard, so it's easy to put back in the right position. Inboard is the end nearest the pump, and outboard is the end away from the pump. If you're working with parts that aren't stamped like this, you might want to make witness marks so you're sure to get them back in the right position. Underneath the top shell are the 2 upper bearing inserts and the oil rings. The inserts have slotted tops to allow the rings to spin freely when the shaft rotates. These oil rings should be handled and inspected with the utmost care. Unless they spin freely, the bearing won't be getting any oil, and even a small burr can be enough to make an oil ring stick. The rings are jointed and hinged to make them easy to remove. Just position the ring with the joint on top. Pull the joint apart and slide the ring out from around the shaft. Set them aside carefully so they don't get damaged. Now we can remove the first bearing insert. This one's stamped outboard. It belongs on the end farthest from the pump. Next comes the inboard insert. We'll inspect it later, after the rest of the bearing's apart. Since the hoist is supporting the weight of the shaft, the lower shell can be rolled around on top of the shaft. Once it's in this position, it can be lifted off without too much trouble. Now the lower bearing inserts can be lifted off one at a time and set aside for later inspection. Just like the other inserts, they're also stamped to mark their inboard and outboard positions. The next step is inspecting the shaft for high spots, scoring, or discoloration. Here we've got some minor scratches, possibly a sign of some more serious problems. Eyes and fingers both play a part in this inspection. The same goes for inspecting the bearing inserts. Since the lower inserts bear most of the load, that's where you look and feel for high spots, scoring, wiping, and discoloration. In this case, we've got scoring. That's why this bearing was overheating. Some particles of grit may have gotten inside, possibly through the lubrication system. If this bearing were badly damaged, it might, in turn, damage the pump seals, packing, or even the impellers. But with light scoring like this, all we'll need is some simple precautionary maintenance. Since the inserts come as a matched set, all four now have to be replaced. After gathering them up, the mechanic makes sure his helper covers the housing with a cloth. That'll keep dust and dirt out while they go to the tool room to get the replacement parts.
With bearings that have removable Babbitt inserts like these, it's easy to replace the entire bearing surface when necessary. But sometimes it isn't that easy. You might have a bearing like this one, with the Babbitt bonded directly to the shell. In that case, you have three options. You can either re-pour the bearing yourself, send it out to have it done elsewhere, or replace both the bearing surface and the shell as a single unit. And this type of bearing also has to be inspected a little bit differently. You check for all the same things, high spots, scoring, wiping, and discoloration, plus one more. You have to make sure that the Babbitt liner is still bonded securely to the shell. One way is to press on the lining, like this. If any oil seeps out along the seam, you know that the bearing's no longer bonded completely. It'll have to be either re-poured or replaced entirely. Well, so far we've seen how a typical journal bearing's disassembled and inspected. When we come back, we'll see how the bearings are fitted to the shaft and how we check the new bearings for the proper clearance and the right amount of contact with the shaft. But before we go on, take a few minutes now to read through section 2 of your text and work the exercises. If you have any questions at this point, go ahead and ask your instructor. When we left off last time, the mechanic and his helper had left the job to go get a new set of bearing inserts for the journal bearing. These are the new ones, right here. But we can't just put them in place and expect the bearing to work properly. First, they have to be fitted to the shaft. This involves two separate operations: checking the clearance between the new bearing and the shaft, and measuring the amount of contact. If necessary, the clearance and the amount of contact can be adjusted by scraping the bearing to fit. Just to give you a little preview, I'll show you what we're going to use to make these measurements. To check the clearance between the bearing and the shaft, we're going to use a couple of pieces of lead wire. If we reassemble the bearing with a piece of lead wire on top of the shaft, the lead will get smashed flat. Then, after taking the bearing apart again, we can measure the thickness of the flattened wire with a micrometer. That'll give us an accurate measurement of the total clearance. Now, where you work, you may use a plastic product that does the same job, but the procedure's exactly the same. We're going to check the amount of contact with this stuff, Prussian blue. If we smear a little bit of this on top of the shaft and then rotate the shaft through the bottom half of the bearing, we'll be able to tell if there are any high spots. If the whole bearing comes up blue, we know we've got good contact. If only parts of it are blue, those are the high spots. What we're looking for is at least 80% contact. If we get any less than that, we'll have to scrape down the high spots and repeat the test until it comes out right. Before we check the bearing for clearance and contact, though, there are three things we have to do. we have to hone the shaft to get rid of some minor scratches left by the scored bearing that we removed. We have to clean the inside of the housing to prevent damaging the new bearing with any grit that's left inside. And we have to clean all the other parts thoroughly. We'll begin then with the first step, honing the shaft.
This process requires two special stones, one coarse and the other fine. First, we use the coarse stone. Before honing, dunk the stone in a container of oil. Getting a lot of oil on it helps the honing process by floating metal out of the stone's pores so they won't clog up. Hold the stone firmly in both hands and smooth out the scratches by honing around the shaft in its direction of rotation. That's the way to get the smoothest finish. Now, normally, you'd have to rotate the shaft to get to the other side, but this is just an abbreviated demonstration of the technique. Once the scratches are gone, switch to the fine stone. This one polishes the shaft and removes any marks left by the coarse stone. Just as before, oil the stone and hone the shaft in the same direction as it rotates for the smoothest possible finish. Once the entire shaft is polished, it's time to clean up the housing and the shaft. Any metal or abrasive particles left over from the honing operation can be cleaned up along with any other material down in the housing. This step can't be emphasized enough. It's dirt or grit that made this overhaul necessary in the first place. The same goes for the other bearing parts. Every one of them has to be thoroughly cleaned before going back in place. Once everything's clean, we can start reassembling the bearing for the lead check. With the new bearing inserts in place in the bottom shell, place the shell over the top of the shaft and roll it in. You may find that a rubber hammer will help you tap it in the last inch or so. When the lower half of the bearing's in place, the next step is to lower the shaft so it once more rests on the bearing surface. Then you can get the sling out of the way and get ready to check the bearing's clearance. First, you have to find out what the clearance is supposed to be. Look it up in the manufacturer's specifications. Then you have to find out whether your leads are big enough for the job. Their diameter has to be larger than the clearance you're going to measure. Check the size of the wires with a 0 to 1 inch micrometer. As long as the leads are both larger than the desired clearance, they're big enough. Now we can place the leads in position on top of the shaft, running lengthwise. We're using 2 leads, so we'll get a reading on each of the bearing inserts. The upper inserts go on next. Before you put them in place, check to see that they're in the correct inboard and outboard positions. The inserts aren't interchangeable. Once both inserts are in place, the upper shell can go on. Again, check for correct inboard-outboard alignment. Make sure there are no burrs or high spots before you lower the shell into position. Next come the dowel pins that lock the upper shell in place. On this bearing, the pins are tapered and seat themselves without having to be hammered in. It's a good idea, though, to double check and make sure that both halves of the shell fit together firmly and tightly. If there were burrs or high spots, you might want to stone the surfaces. Even though the shell is now in place, we're still not ready to remove the leads and measure the clearance. The bearing housing also has to be in place and torqued down to the proper value before we'll get an accurate measurement. Before you put the housing on, though, make sure there's a gasket on it. If there isn't, your clearance reading will be smaller now than it will be when you replace the gasket during the final assembly. Now, be careful when you lower the housing into place. Some of these things are heavy, and you don't want to pinch your fingers. The safest way to handle it is with a finger through each of the observation holes. Next come the housing nuts. Screw them on by hand. Snug them down with a wrench, and then torque them to the proper value. Whenever you torque down housing nuts, use a crisscross pattern. After you get one, go to the diagonal corner. Keep going across opposite corners until each torque readings according to the specs. That way, the housing's tightened down evenly along all its edges. Once the housing's torqued down tight, and the leads are smashed as flat as they're going to get. It's time to start removing everything again. Unscrew the nuts, lift off the housing, pry out the pins holding the shell together, and lift off the upper shell. Now we can remove the two upper bearing inserts and mic the leads. When you measure them, check them in several places along their length. You're looking for the largest reading on the flattened part of the lead. High spots will show up as slightly smaller readings, but we'll take care of them after we do the bluing test. After measuring both leads, lock your micrometer and check the manufacturer's specs. You have to be careful, though, because manufacturers can list the clearance in either of two ways. They can specify either the total clearance or the running clearance. When we performed the lead check, we measured the total clearance, the gap between the top of the shaft and the upper bearing surface while the shaft is at rest. The running clearance, though, is a different story. When the shaft's rotating in an oil film, it doesn't lie on the bottom of the bearing. It's almost centered. Usually, it'll ride a little closer to the bottom of the bearing, just because of its weight. The average running clearance, then, is half the total clearance. In this case, the manufacturer specified the total clearance, and this bearing's right on spec. Now we're ready for the next part of the fitting procedure, the bluing test. In this test, we're going to use Prussian blue to check for high spots on the bearing. If we find any, we'll have to scrape the bearing to fit the shaft. The Prussian blue goes along the top of the shaft in a thin, even coat. Spread it with your finger until the layer extends over the entire journal. You have to be careful about going overboard with the blue. If you build up too thick a layer, you might get a deceptive result. The bearing will look like it's in good contact all the way around, even though you might have serious high spots. The next step is to rotate the shaft one complete turn so we can see how much contact we have between the bearing and the shaft. For that, we use a strap wrench. Attach it to the shaft so you can turn it in its normal direction of rotation. Then, rotate the shaft. As it turns, the line of Prussian blue is wiped across the entire surface of the lower bearing. When it gets back up to the top, we'll be able to check both the shaft and the bearing and see just where the high spots are. Looks like we've got some problems. Each of these breaks in the pattern correspond to high spots on the bearing. The blue places in between are spots where the bearing didn't touch the shaft. After hoisting the shaft and removing the bearing, we can compare the two patterns. The blue places on the bearing match up with the blank spaces on the shaft. On the bearing, the blue places are the high spots, and where the blue didn't transfer, the bearing and the shaft didn't touch. Since this is obviously less than 80% contact, we'll have to scrape the bearing to remove the high spots. This job's done with a tool called a bearing scraper. They come in all shapes and sizes, so don't be surprised if the ones at your plant don't look exactly like this one. The technique, though, will be the same. To make the bearing fit the shaft, you scrape the blue places, the high spots on the bearing. This can sometimes be a pretty time-consuming operation. It takes a while to do the job right. However, since this is only a demonstration, we'll cut it short here and repeat the test so you can see what a good result looks like. The steps are the same the second time around. After applying the Prussian blue, rotating the shaft, and rolling out the bearing, here's what you should have. A nice even coat of blue over the shaft and the bearing. At least 80% of both surfaces should be blue. If this is what you come up with, you've done a good scraping job, and the bearing's ready to go back together.
In this section, you've learned two of the basic techniques used to fit a split journal bearing to a shaft. You've seen a lead check for clearances and a bluing test for high spots. We also had a demonstration of scraping a bearing. To remove the high spots, you scrape away the blue parts of the bearing surface. Even though the journal bearings used at your plant may be different from the one in our demonstration, these techniques will stand you in good stead whenever you have to fit a split journal bearing to a shaft. So before we go on to the reassembly stage, Read through Section 3 of your text and make sure you've got a handle on everything we've covered so far.
Every good bearing reassembly begins with cleaning all the parts. When we left off, the mechanic had finished the bluing test. So the first step in the reassembly is wiping the Prussian blue off the shaft and cleaning the housing. If you stuff a rag into the oil drain to keep from dropping dirt and parts down the hole, be sure to remove it at this point. Once the bearing's back together, it's a little too late to remember. The other bearing parts, including shells and bearing inserts, also have to be cleaned. Even small grit particles can eventually destroy a bearing. The first parts to go on are the lower shell and its two bearing inserts. After making sure that everything's in its correct inboard or outboard position, lower the shell onto the top of the shaft. Once it's in the right position, you can roll it down and around to the bottom of the shaft. To sink it down flush with the housing, it may be useful to give the shell a few raps with a rubber hammer. When the shell's in place, you can lower the shaft into position. Now the weight of the shaft is resting directly on the lower bearing. We won't be needing the sling and hoist again, so we can go ahead and get them out of the way. Now it's time to install the upper bearing inserts. Before putting them on, though, make a last check to make sure that they're clean and that they're going on in their correct positions. Since the inserts are made of babbitt, a soft metal, it doesn't take much to scratch them up. When you install them, fit them into place gently. Otherwise, you may be repeating this overhaul sooner than you think. Once the upper inserts are in place and lined up with the inserts in the lower shell, the oil rings can go on. It's easiest to hinge them around an exposed part of the shaft. Snap them together and then slide them over to the slot in the top of the bearing insert. Give them a quick test spin just to make sure they're not getting hung up on anything. The oil rings are very important to the operation of the bearing. They bring oil from the bottom of the housing up to the top of the shaft, and if the rings can't spin freely, the bearing won't get any lubrication. Make sure they're positioned correctly and that they're free to rotate before continuing with the reassembly. The next part to go on is the upper bearing shell. Before you install it, make sure it's clean and check the markings to make sure that the inboard end points toward the pump and the outboard end points away from it. When you lower the shell into place, line up the grooves in the shell with the ridges on the bearing inserts. That puts everything in the right position. Next come the pins that lock the two shell halves together. Since this bearing has tapered pins, they have to be put in the right way, but they'll snug themselves down without hammering. When both of them are in, make sure the shell halves fit together tightly, and spin the oil rings one more time to make sure they're still free to move. Before the housing goes on, there's one more important step, a new gasket. To ensure that the housing seals correctly, always follow the manufacturer's recommendations on gasket material and application. In this case, a fiber gasket is recommended, and it has to go on in two parts to leave a space for the pump shaft. Once the gaskets are in place, the only remaining part is the upper housing. But before lifting the housing, this mechanic puts his gloves on. They'll help protect his fingers when he holds the housing and lowers it into place. Now, this bearing housing is heavy enough to require careful lifting, but with a really large housing, you may need a hoist to get it into position. Before you put the housing in place, check to make sure that the old gasket's been scraped off completely. With this housing, the best way to lower it into place is with a finger inside each of the observation holes. Lower it down over the studs and check the fit to make sure it's tight all around. Next come the housing nuts. Screw all four of them down by hand. Tighten them with a wrench and torque them down to the correct value using a crisscross pattern or the tightening pattern recommended by the manufacturer. Well, Now we've got the whole bearing back together, but we're not quite done yet. Before moving on to the next bearing, we have to add some oil to this one. We're going to prime the bearing by pouring oil down the observation holes. Later on, we'll fill the entire reservoir and prime the bearing once again before starting the pump. But one important point is to check the specs and add only the grade of oil recommended for the bearing. Pouring oil down the observation holes just helps the bearing get started. So when we check it now, it's lubricated, even before the oil rings start pulling oil from the bottom of the housing. Rotate the shaft a few times. For that, we use a strap wrench. Attach it to the shaft so you can turn it in its normal direction of rotation, just to make sure that everything turns freely without binding or hanging up. Then, replace the plugs covering the observation ports and reinstall the gland follower. Now we're done.
Well, that about covers it for journal bearings. You're sure to find some differences between our example here and the bearings used at your plant. But the procedures and techniques we've seen are typical of many kinds of journal bearing maintenance. We've seen how this bearing here was disassembled, inspected, tested, and reassembled. In each step along the way, we mentioned a few of the differences you're likely to encounter with other kinds of journal bearings, and talked about the safety precautions you need to use when you're doing this kind of work. In a few minutes, we're going to go on to see some typical maintenance procedures for tilting pad thrust bearings. That's the bearing over on the other end of the pump. But before we continue, read through your text and review what we've learned about journal bearings and their maintenance. In the next two sections, we're going to be taking a look at some typical maintenance procedures for testing, disassembling, and reassembling tilting pad thrust bearings. Now, you already know what thrust bearings do. They handle axial loads, a shaft's tendency to move lengthwise. With that in mind, let's briefly review the parts of a tilting pad thrust bearing and see how it does the job. This part of the bearing is the thrust assembly. It consists of a thrust collar, keyed to the shaft, and two sets of thrust shoes, one set inboard and one outboard. Each set of shoes is held in place with a support bracket. There's a small clearance between the collar and the shoes, so the shaft has some freedom of axial movement. But that movement is restricted by the shoes and the brackets. The amount of travel allowed by the shoes and the brackets is the total clearance of the thrust bearing. Before we remove even the first bolt on this bearing here, we're going to measure that clearance. It's called taking a thrust reading. We're going to do it with this device, a dial indicator. In case you haven't seen one of these before, here's how it works. You see this button on the back. When you push on it, the needle registers the movement on the dial. So what we're going to do is mount this on the coupling and then move the shaft back and forth lengthwise, letting its axial movement register on the dial. That total axial clearance is the thrust reading. We'll begin with the first step, mounting the dial indicator on the coupling.
The first requirement is to create a firm, rigid base to which the indicator can be attached. Since we're measuring the axial movement of the pump shaft, this piece will have to be mounted on the motor side of the coupling. Now, this is just an example of one way to rig the apparatus. In this case, we're using a roller chain and a clamp to make a solid base for the indicator. You have to snug it down tightly to make sure it won't slip later on. The next piece to go on is called the indicator clamp. It mounts on the clamp that goes around the coupling. This part, called the indicator post, is where we'll mount the dial and the lever. The lever is positioned so that it rides on both the pump side face of the coupling and on the button in the back of the dial indicator. When the coupling moves this way, the lever pivots, pushing in on the indicator button. That way, when we move the shaft in either direction, we'll get a reading on the dial. When everything's securely in position, it's time to move the shaft toward the motor and zero the indicator. One way to move the shaft is to pry it, but make sure you pry against something that won't be damaged by the metal bar. Here, we've already removed the gland follower to make the job easier. Now, we go back to the other side to set the dial on 0. You zero a dial indicator by turning the outer ring on the dial until the needle points to 0 on the scale. Then, it's time to move the shaft the other way by prying between the coupling faces. Now we can take the first reading. Uh-oh. The thrust reading slightly over 20 thousandths, and the maximum clearance should be 17. And just to make sure, we'll repeat the reading in reverse and see if the indicator reading returns to 0. First, lever the shaft toward the pump as far as it will go. Then check the reading. It should read 0. And it does. That means that our reading of 20 thousandths is accurate. The total axial clearance is too great, so we've got a maintenance job ahead of us. The most likely explanation of this excessive clearance is worn thrust shoes. And since this pump primarily creates an outboard thrust, the outboard thrust shoes are probably the ones that need replacement. To find out for sure, though, we have to disassemble the bearing and inspect the shoes directly. And just like any other bearing disassembly, the process begins with cleaning the outside of the housing, so no dirt or grit will accidentally fall inside. Then the housing can be unbolted. Just like on the other bearing, this housing is secured by 4 nuts. But this one also has a couple of extra features. It's easiest to remove the top of the oil pump along with the housing, so you have to take out all of the bolts that hold it in place. Loosening the centering bolt on top of the housing also makes the housing easier to remove. This is simply a bolt that extends through the housing and projects into a hole on the shell. It holds the shell in place so it doesn't rotate in operation. The next step is to pull the plugs out of the observation ports, set them aside, and lift the housing off. This one's heavy enough to make it a 2-man job. Since the lower housing contains the oil reservoir for both pump bearings, we have to drain it before going any farther. On this bearing, you drain the oil by disconnecting the oil drain pipe at the union. The next step is to hang a hoist, arrange the sling, and start hoisting the shaft to take the weight off of the bearing. Once you feel the sling getting tight, you've hoisted far enough. With the shaft supported by the hoist, we can remove the upper bearing shell. This one's held together by 4 dowel pins. This shell's different than the one on the other bearing. Once the housing and the centering bolt are removed, it can be rotated in its housing. Stick a wooden dowel into the centering hole and turn. Now we can get to the bottom of the pins and knock them out with a pin punch and a hammer. This way, you don't have to pry the pins out and run the risk of damaging the edges of the housing. But you do have to be careful not to drop the pins. It's all too easy for one of them to fall into the oil drain. Once 2 of the pins are out, rotate the shell in the other direction. Now we can get to the pins on the other side. Rotating the shell and punching the pins out from the bottom is always the preferred method, when it's possible. The only reason we pried the pins out on the first bearing is that the shell wasn't designed to rotate in its housing. Once you've knocked out all 4 pins, return the shell to its original position. Then remove the wooden dowel and lift off the upper shell. As we mentioned earlier, this bearing has journal bearing parts as well as a thrust assembly. Therefore, we'll have to inspect the inserts, just as we did on the first bearing. We'll also have to do a lead check and a bluing test, but since we've already seen the details of both of these operations, we'll skip over them here and continue with the disassembly of the thrust bearing. The next step in the disassembly is to roll the lower shell up and around the shaft until it's on top. Then we can lift it off. Once we get it out of the way, we can start taking apart the thrust assembly itself. Once the lower shell is removed, you can simply slide the support brackets aside. one at a time, and remove the thrust shoes. Unfortunately, most of the shoes will fall to the bottom of the housing as soon as the brackets are moved. There's no way to keep them from dropping, so you just have to pick them up where they fall. Once you've got all the shoes, inspect the thrust collar for uneven wear, scoring, or discoloration. This one seems to be okay, so the next step is to inspect the shoes. Select one inboard and one outboard shoe. That way, you can compare the amount of wear on each one. Since the thrust on this shaft's primarily in an outboard direction, we'd expect the outboard shoes to show a greater amount of wear. And that proves to be the case. The outboard shoe has definitely worn thinner. Most of the difference shows up here. The trailing edge is the point of maximum wear on any thrust shoe. Well, now we've got our work cut out for us. We'll have to replace or resurface the outboard set of shoes. They're the reason for the excessive axial clearance we found when performing the thrust reading.
Whenever you have to replace any thrust shoe, you have to replace the entire inboard or outboard set. If you only replaced one or two, they'd be thicker than the rest, and since they'd be taking most of the load, they'd burn out quicker. In general, you've got three options when worn thrust shoes are the problem. You can pour new Babbitt surfaces, you can send the shoes out to be repoured, or you can replace the entire set. Now, if the collar were damaged, it would have to be replaced or dressed. In this case, we're going to replace the outboard set of shoes. In the next section, we'll see how they're installed and how to reassemble the bearing and set it up for a test run. But first, make sure you understand the steps we've seen so far, especially how to take a thrust reading. You'll find more detail in your text, and your instructor should be able to compare what we've seen here with the equipment and procedures used at your plant.
So far, we've seen how to take a thrust reading and how to disassemble and inspect a tilting pad thrust bearing. We determined that the outboard set of thrust shoes were worn and needed replacement. In this section, we'll see the new shoes installed and the rest of the bearing reassembled. Then we'll test the pump and both its bearings to make sure everything's been fixed. Just as before, the first step in the reassembly process is cleaning the shaft and the inner housing and plugging the oil drain with a rag to prevent dropping dirt and small parts into the oil system. We also have to clean all the other parts. If we're going to keep this bearing running, we've got to keep dirt and grit out. Here are the new parts, a set of outboard thrust shoes. They'll go into place as a complete set. It's a lot easier to put the shoes in if you've got them laid out within reach before you start. The best way is to arrange all the inboard shoes on one side and all the outboard shoes on the other. After placing the brackets in their approximate positions, there's one more thing you can do to make the tricky job of installing the shoes a little easier on yourself. Pour some oil over the brackets and the thrust collar. Oil will help the shoes stick to the surfaces, so it's easier to position a shoe without dropping the ones you already have in place. Now, we're ready to start installing the thrust shoes. We'll begin on the inboard side. Keep the retainer close to the collar and slip the first shoe in between. A recess on the back of the shoe fits onto a small pin on the bracket. Then, rotate the bracket and place the next shoe. This is the trickiest part of the job, installing the rest of the shoes without dropping the ones you already have in position. It may take more than one try before you get a complete set installed. Here, on the outboard side, it's a little easier to see what's going on. After slipping the first shoe into place, make sure it's firmly seated on its pin. Then, rotate the support bracket, and while you hold the first shoe in place, slip in another one. The first couple aren't too difficult, but after that, you have to be careful to apply enough pressure to the bottom of the retainer to keep the first shoes in position, while allowing just enough space on top to install the next one. It gets a little bit trickier as you go along. The more shoes you have in place, the harder it is to keep them there while you insert the next one. The first few times you do this, you're bound to drop the shoes at least once, but don't let it rattle you. With practice, you'll be able to do it as smoothly as you see here. The main point is that you get each shoe seated firmly on its pin before you go on. And each time you slip in a shoe on top, you allow just enough clearance for the shoe. If there's too much of a gap, at least one of the other shoes will fall off. Well, it looks like we got them all this time. You can make sure by rotating the support bracket and checking to see that all the shoes are still seated. After this, the rest of the reassembly is easy. Check the lower shell and its bearing inserts one more time to make sure they're still clean. And place the shell over the top of the shaft carefully. The lower shell is what holds the retainers together. So while you're seating it over the thrust assembly, a little bump in the wrong direction could upset everything you've done so far. After rolling it in as far as possible by hand, you may still have an inch or so to go. That's when you resort to a tool that we've had occasion to use earlier, a rubber hammer. A few taps should be enough to sink the shell flush with the lower housing. The next step is oil. Before putting the upper shell in place, make sure that the thrust assembly is thoroughly lubricated. And remember, whenever you pour oil on a bearing, even to stick on the thrust shoes, use only the grade of oil recommended by the manufacturer. Otherwise, the additives in the different grades of oil may react chemically with one another, with bad consequences for lubrication. Next, tap down the pins that hold the retaining rings in position. The pins fit into notches on the lower shell, so when the shaft rotates, the retainers and thrust shoes don't. Now you can lower the shaft and remove the sling. The shaft's weight now rests directly on the lower bearing. Then, after checking for the correct inboard-outboard position, place the upper shell over the top of the shaft and push in the dowel pins. Next comes a new gasket. Be sure to make it from the right kind of material, so the bearing housing won't leak oil. Now you can carefully place the upper housing in position and screw in all the nuts and bolts that secure the upper halves of the housing and the oil pump. Be sure to torque down all the nuts and bolts to the manufacturer's specs. Tighten the centering bolt so the shell is locked in place. And repeat the thrust check, just to make sure that nothing slipped during the assembly, and the clearance still matches the specs. Now, before starting up the pump for a test run, we've got to get the lubrication system in order. Tighten the union on the oil drain pipe, and fill the reservoir by pouring oil through the observation holes until the level reads midway up the sight glass. Then prime the journal bearing one more time and replace the plugs. The last piece to go back on is the gland follower. Now we're ready to recouple the pump, report to a supervisor, and get the pump turned on for a test run. The test run will probably take a few hours. While the pump's running, check the bearing's oil temperature frequently. On the journal bearing, look down the observation holes to make sure that the oil rings spin freely as the shaft rotates. After a few hours, have the pump turned off again so you can repeat the thrust reading one more time. Now, if everything reads okay, the job's done.
While you're testing a set of bearings that you've just worked on, look for three things: abnormally high temperatures, excessive vibration, or unusual noises. Any of these symptoms indicate trouble. If you do notice anything that doesn't seem right, stop the machine immediately and find out what's causing the problem. Temperatures, for example, will go up as soon as the shaft starts rotating, but they should level out pretty quickly. You'll be able to find the bearing's normal operating temperature by looking at your plant's maintenance records for the machine, or by referring to the machine's operating records. Well, we've learned quite a bit in this session. We looked at two kinds of sliding surface bearings, a journal bearing and a tilting pad thrust bearing. And we've seen how each of them is taken apart, inspected, repaired, and reassembled. The bearings you work on might be a little different, but most of the techniques we've seen today will apply. Some of them take practice, but that's all part of being a mechanic. Hopefully, you'll get some practice in the classroom before you go out and work on sliding surface bearings in the plant. Undoubtedly, you'll discover a few helpful techniques on your own. But whatever the case, get to know the bearings in your plant, so when you fix them, they'll stay fixed.